Good morning, children. So last class we have discussed up to the salient features of periods and groups. Okay. So today we are going to start the new topic, periodic properties. So what are the properties are called periodic properties? Okay. Then we will see one by one. Okay. First one, atomic radius. Second one, ionic radii. Third one, ionization energy. Fourth one, electron affinity. Fifth one, electronegativity. So these properties are called periodic properties. Okay, so if you are looking the periodic table, okay, how many periods are there, how many groups are there? So why we want to analyze the periods and the groups? So based on their certain properties. Okay, so that properties are called periodic properties. So how many properties are given in our textbook? 5 properties are given. Okay, so first one we will see atomic radius. So first property, atomic radius. So what is mean by radius? So already we have learned from the lower section. So half of the diameter is nothing but radius. Okay. So if you are drawing the circle, okay, the center point to any side of the boundary is called radius. Okay. The same way we have to measure the atomic radius of the particular element. So how to define the definition for atomic radius? So atomic radius of an element is defined as the distance between the center of the nucleus and the outermost cell contains the valence electron. So for example, okay, if you are drawing the electronic configuration of particular atom of an element, okay, the center part of the nucleus to outermost cell contains valence electron. Okay, the in between the distance is called atomic radius. Okay, in between the distance is called atomic radius. Okay, so atomic radius of an atom is defined as the distance between the center of the nucleus and the cell, okay, outermost cell contains the valence electrons. Okay, so the direct method is not applicable to find out the atomic radius. Why? It is not stable. Okay, so either the atom is the combined state or in the molecule form we can measure the atomic radius. So atomic radius can be classified into two types. Okay, one is covalent radius, another one is metallic radius. Okay, so one is covalent radius, another one is metallic radius. Okay, one is covalent radius, another one is metallic radius. Okay, the metals forms metallic radius, non-metal forms covalent radius. Okay, so if you are taking the ion, so what type of radius it will form? Metallic radius. So if you are taking the hydrogen, it will form covalent radius. Okay, covalent radius. Okay, so first one, metallic radius. So if you are taking two types of metals, okay, or same type of metal, okay, the center part of the nucleus, here also center part of the nucleus, so we have to measure the distance. Divided by 2. Suppose A, B, okay, so radius is equal to R is equal to AB divided by 2. So how to define? It is defined as the half of the distance between the nuclei of adjacent metal atoms. Okay, half of the distance between the nuclei of the adjacent metal atoms, okay, near the metal atoms. Okay, so that is called a metallic radius. The same way we have to define the covalent radius. Okay, so covalent radius, which type of atom of an element it will form covalent radius? Non-metallic. Okay, non-metallic. So if you are taking the hydrogen molecule, okay, hydrogen molecule H2 example. Okay, this one molecule, another one. So in between Okay, so A, B. Okay, so radius equal to what? AB divided by 2. Okay, so textbook itself value is given. So AB is equal to 0.74. 0.74 divided by 2. So what is the answer? 0.37. 0.37 Armstrong. Okay, so in this way we have to find out the atomic radius. Okay, atomic radius. Okay, the same properties we will see. Okay, period and group. Okay, so period means we know. Okay, if you are looking the periodic table. So, okay, so which part is called period, which part is called group. Okay, so this is the periodic table. Okay. So horizontal lines are called periods. So vertical lines are called groups. So what will happen? So atomic radius, what will happen in the periods and the groups? Okay. So if you are looking the period, atomic radius decreases. Okay. So in this way decreases. So in this way increases. Okay. So why? Because why does decreases? Okay, so if you are taking the, for example, if you are taking the lithium and beryllium, lithium and boron, okay, lithium 3, boron 5, okay, so here how many protons are there? 3 protons are there, okay, the same way boron 5 protons are there. Okay, so increasing the proton, it will not release the electrons very easily. The same way, if we are seeing the group, okay, if you are seeing the group, okay, atomic number also increased. Okay, here atomic number gradually increased. Okay, gradually increased, but here, okay, the atomic number increases, showing, okay, various. So this is the reason. Okay, atomic radius, okay, along the group increases, along the period decreases. Okay, so second properties we will see. Atomic, so first properties is over, atomic radius. Second property is ionic radii. Ionic radii. So what is mean by ion? What is mean by ion? So any charged particles called ion. So lithium is a neutral atom. Lithium plus, that is called charged particle. So it is called as cation. Okay, it is called as cation. So suppose any an atom lost one electron, becomes cation. Becomes cation. The same way any one atom of an element gain one electron, becomes anion. Okay, this is called cation. Okay, this is called cation, anion. So what is mean by ionic radii? What is mean by ionic radii? Okay, suppose any one of the atom of an element becomes in a neutral state, the same way ionic state we have to measure the radius. We have to measure the radius. For example, okay, the center part of the nucleus to outermost cell. Outermost cell contains the valence electron. So we have to measure the distance. So that is called atomic radius. Atomic radius. So what is mean by ionic radii? Okay, suppose the electron clouds. Okay, if you are taking one atom, okay, the outermost cell contains the number of electron, it may differ. Okay, the center part of the nuclei to up to which the outermost electron contains, okay, it exerts the force. Okay, so in between the distance is called ionic radii. Ionic radii. So ions means charged particles. Okay, suppose any one of the atom gain the electron, okay, that is called anion. Lost the electron, it is called cation. The same way ionic radii also along the group increases, along the period decreases. Okay, so second one, ionization energy. The third one, ionization energy. Third one, ionization energy. Ionization energy. So what is mean by energy? So energy is nothing but ability to do the work. Okay, so if we want to complete any work, we need energy. The same way ionization energy. So what is mean by ionization energy? So the minimum amount of the energy required, the minimum amount of the energy required to remove an electron, to remove a electron from gaseous state of an atom in its ground state. Okay, so if you are taking the gaseous state of an atom, we have to keep in which state? Ground state. Okay, so we have to remove the one electron. We have to remove the one electron. So how much amount of the energy is needed to remove the one electron? For example, okay, this is the atom. Okay, gaseous atom. Okay, what type of atom we have to take? Gaseous atom. Okay, so we have to remove the electron. We have to remove the electron. Okay, we have to remove the electron in which state? Ground state, not in the existent state. Okay, we have to remove in the ground state. So how much amount of the energy we have to give? Okay, that energy is called ionization energy. So what is the unit used to measure the ionization energy? Kilojoule per mole. Okay, that ionization energy is otherwise known as ionization enthalpy. Okay, ionization enthalpy. Ionization enthalpy. Okay, these are all the information is given in the ionization energy. Okay, the same way as the positive charge increases, the ionization, the size of the cation also decreases. Okay, so next one. This is called fourth one. So fourth one, electron affinity. Electron affinity. So what is the difference between ionization energy and the electron affinity? So ionization energy, how much amount of the energy needed to remove an electron from gaseous state of an atom in its ground state. So electron affinity is nothing but, okay, how much amount of the energy released when a gaseous state of an atom gain an electron to form an ion. Okay, for example, chlorine accept one electron to form Cl minus. It is called an ion. Okay, how much amount of the energy? How much amount of the energy released? Okay, when one atom of an element accept one electron to form an ion. Okay, so that is called electron affinity. Electron affinity. So electron affinity and ionization energy just opposite. Okay, so next one, electronegativity. Electronegativity. So electronegativity. So electronegativity of an element is the measure of the tendency of its an atom to attract the shared pair of electrons towards itself in a covalent bond. Okay, for example, so if you are taking the hydrogen chloride, okay, this is a HCl atom, it's a chlorine atom. So which one has the more electronegative power? Chlorine. Okay, when compared to hydrogen has the more power. Okay, suppose we may break, okay, the lone pair of the electron, it will go which side? Chlorine side. Already we know what is meant by covalent bond, mutual sharing of the electron. Okay, hydrogen also shared one electron, chlorine also shared one electron to form covalent bond. Okay, suppose we may broken that bond or break that bond, what will happen? The shared pair of the electron move towards itself to the chlorine atom because of the negativity. Because of the negativity. Using Pauling scale. Okay, which scale is used to measure the electronegativity? Pauling scale. Okay, is used to measure the electronegativity. Okay, so sum of the atom of an element, the electronegativity value is given. For example, okay, for example, fluorine 4.0, chlorine 3.0, bromine 2.8, iodine 2.5, hydrogen 2.1, sodium 1, sodium 1. Okay, so based on this we have to find out the which type of bond. Okay, if the difference of the electronegativity between two elements is 1.7, the bond has 50% ionic character and 50% covalent character. Okay, if the electronegativity value, okay, greater than 1.7, okay, less than 1.7, okay, this one, what is the meaning? Okay, greater than 1.7. Okay, suppose here one value is, that means increasing this one. Okay, this one less. Okay, greater than 1.7, the bond considered to be a covalent. Okay, if the difference is less than 1, sorry, if the difference is less than 1.7, the bond is considered to be a covalent. If the difference is greater than 1.7, the bond considered to be a ionic. Okay, for example, we will calculate for hydrogen and chlorine. Okay, hydrogen and chlorine. Hydrogen is equal to 2.1, chlorine is equal to 3.0. Okay, so is equal to 5.1 divided by 2. Okay, 2 2s are 4, remaining one 5, 2.5. Okay, the value is greater than 1.7. The value is greater than 1.7. So this HCl showing what type of bond? Greater than 1.7. It is showing in ionic bond. Okay, 2.55. Greater than 1.7. So less than 1.7, that is covalent bond. Greater than 1.7, that is considered as a ionic bond. So in this way we have to find out the electronegativity value. Okay, so that's all. Okay, just we will see the comparison of the period and groups. So properties. Okay, first one, atomic radius. Second one, ionic radii. Third one, ionization energy. Fourth one, electron affinity. Fifth one, electronegativity. Okay, so if you are taking the period and group, okay, here decreases, here also decreases, here increases, here also increases. Okay, the same way ionization energy, electron affinity and electronegativity, here increases, here increases, here decreases, here decreases. Okay, this is the one of the shortest method we have to keep in the what are the properties, what will happen in the along the group and along the period. Okay, so today we have discussed up to the periodic properties of an element. Okay, so thank you children, we will see in the next class. So remaining part we will see in the next class. Okay, thank you.